can I use the power rule on this, or do I have to use law of differentiation? Oh, look, the directions say to use law of differentiation, so you don't have to think about it. But it's an x to an x power, so you can't do the power rule. If it was an x to a number, even if it's a weird number, you can do the power rule. So I'm going to ln both sides. So look how cool this turns out. Right? When you bring that out front, you get ln of x times ln of x. So you have two options here. One option is that's a product, so you could do the product rule, like take the derivative of one times the other plus the derivative of the other times the first. Another option that I helped the people with yesterday is they wrote this as ln of x times ln of x would be ln of x squared. So another option would be you could do the chain rule, because if you have two ln of x's. I don't care which way you do it, you get the same answer either way. When you look in the back of the book, they have an x ln of x in their answer, and that's because you have to multiply by y over at some point, so always remember that when you're doing this. So if I took the derivative of this, I don't know which one I'm going to do, but I'm going to say that's 1 over y times dy dx. And I'll do both ways just to show you. If I did the product rule, the derivative of ln of x would be 1 over x times ln of x plus 1 over x times ln of x. That would be the product rule. Or if you did the chain rule, that would be 2, leave the inside alone, times the derivative of the inside, would be 1 over x. And you do really get the same answer either way, because this is just 2 ln of x times 1 over x. This you would have ln of x over x plus ln of x over x. Common denominator, ln of x plus ln of x, happens to just be 2 ln of x over x, which is exactly what you got up here. So that's why it doesn't matter which way you do it, as long as you do the calculus correctly.
If you just did 2 over x times ln of x,
Yeah, that's the same thing. I tend to just write it as a fraction, like all one fraction. And then you're trying to solve for dy over dx. So that's where the back of the book has that original problem in there, because to solve this, you're going to multiply both sides times y. And remember, we always replace y with what it equaled, which in this case was x to the ln of x. And again, it doesn't really matter in which order you put that in. You're multiplying. You're allowed to multiply in any order that you want. So it's however you want to do it. If there's a denominator, I tend to write it as one big fraction. I'm not going to mark it wrong if you don't do that. But it doesn't matter whether you put the x ln of x by the 2 or whether you put it at the end. It really doesn't matter. I think I'm just going to write it up here, and then ln of x all over x. I cannot cancel this x out with this x because it's in the ln. I cannot cancel this x out with this x because it's to the power ln of x. So I think that's the answer that I can go with. Or some version of that. Yes.
Okay, on 41, I don't really have a question, but like, when you look at these, because I got like a 2 on the top, and they got like a 3 on the top in the back of the book, and I wasn't sure like if.
Well, the u prime is going to be a 3, right? So shouldn't you have on the top here? If this isn't your u 3x plus 1. Like, why did you make your u 3x plus 1 squared? I think you just made that squared.
So it's, you don't put that to it, right?
No, that's your base. And so that's the only thing you do with that in your derivative is the ln of 2. That has nothing to do with the u.
Gotcha. Cool. Thanks.
if you look at 55, I think I got A, but the rest I missed.
55 says, let f of x equal 2 to the x. Find f prime of 0.
So that one you just find it with
Yeah, and so this is the a to the x, right? You don't have to do logarithmic differentiation on this because this is a number, this is an x, so that fits the formula of a to the x. And so the derivative of a to the x is a to the x times ln of a. So that would be 2 to the x times ln of 2. So then they ask you to plug 0 in there, so you get 2 to the 0 times ln of 2, which is just ln of 2. This is kind of a looking for a pattern problem here. And so part B says use the definition of the derivative to write this as a limit. It's been a while since we did the definition of a derivative as a limit, but parts C and D are kind of giving you the hint of what to do there. But definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Any memories of that? There's the alternate form of a definition of a derivative, but looking at C and D, since they're talking about h approaching 0, that's how I knew to use this definition of derivative. And so it says write the derivative at 0. So they're telling me that x is 0. So I can even go as far as saying I'm just going to do f of 0 plus h, which is f of h, minus f of 0 all over h. And I just plugged in 0 for h, because that's the value I'm finding the slope of. So if I do f of h, I would just replace x with h, and I would get 2 to the h, minus, if I plug 0 for x, I would get 2 to the 0, which is 1, all over h. They don't ask you to evaluate this limit, because using what we did in chapter 2 and the beginning of chapter 3, it doesn't really fit any of our shortcuts. We can't really factor it, we can't really do a lot to simplify it. But what they want you to do is look at that answer to try to use some, I don't know, deductive reasoning to figure out what C and D are. But that's really the answer for part B. Write it as a definition of a derivative. So then on part C, it says, oh, deduce, there you go, deductive reasoning, the exact value of the limit as h approaches 0 of 2 to the h minus 1 over h. Which means they don't want you to make a chart. They don't want you to, like, you know, try to pick values closer and closer to 0. They want you to say, oh, this is the derivative of 2 to the x at 0. Did I already find the exact value of 2 to the x at 0? It was element 2. What has happened on the AP test in the last few years on the multiple choice part, the no calculator part, they give you questions like this, and they just want you to recognize, oh, it's the derivative. That's the derivative formula. So what's my function? Oh, it's 2 to the x is my function. So what's the value I'm finding it at? Well, if there's only an h up there, then my value's at 0. And so that's how they can put the definition of a derivative on the test, is they can write the question like this and ask you to recognize what it's saying. So then part D says find the limit as h approaches 0 of 7 to the h minus 1 over h. And you really don't have much to go off of except for the pattern that's happening here. If 2 to the x derivative, when you plug 0 in, was ln of 2, this one looks to me like it's just changed to 7 to the x. So following the pattern, I would say, based on the information given, I would just say ln of 7. And it's just kind of like following that pattern there is what they're wanting you to do. Not really work involved. Which makes it hard on problem to feel like you didn't come down that close. Right?
For the first two, I did it with logarithmic differentiation of the first two, and then I looking back and looking like, how did I even get this? And I'm like, oh, you said this.
Yeah, yes. Yeah, so really, and as we review for our test, really important to recognize that you don't have to do logarithmic differentiation on a problem like this, because it's a number to a power, and we have a formula for that. So you don't want, sometimes log differentiation, when you do it and you don't need to do it, it gets kind of crazy. Yes, dear. Last one. I asked you to find domain on this. That's kind of just a nice reminder about the domain of ln functions. Ln, the derivative of ln of u is u prime over u. So if I'm going to do the derivative of this, the derivative of x plus 2 is just 1 over u, which is x plus 2. They talk about domain of the derivative because they want you to keep in mind that the domain of the derivative, you have to carry over the domain of the original function. So if I asked you just for the domain of this, you would say, x can't equal -2 because it would make the denominator go to 0. But if you look in the back of the book, you'll see that they say the domain is x is greater than -2. No. Yes. Because you can't take the ln of 0, you can't take the ln of a negative number, so not only do you have to exclude what made that go to 0, because it's a fraction and there's x in the denominator, but you had to carry over the domain of ln. Because if your function isn't defined there, it's not going to have a derivative. So that's what they're making you think about. If I asked you to find the derivative at -7, you couldn't because there is no -7 on the function. The function doesn't exist there. So that's why they ask you about domain, because they want you to keep in mind that the domain of the original function carries over. Homework quiz. Homework quiz.
I should have worn my I Heart Cat.
This is from 3.8 and 3.9 because although you had a 3.8 worksheet on Monday, we had that derivative quiz. We haven't had a homework quiz over 3.8, so 3.8 and 3.9. Maybe I should